emergency. It's perfect. That's perfect. No. Zoom all the way in. And just zoom in on Fred and back. He watches them, so he just watches himself. Melody, I don't know how to start this out. All right. Oh, we have it next.
So,
yes.
you never had a pen to write this?
Yes.
You can say no and then get an excuse of not.
No.
I don't have a.
Oh, then no, definitely not. Oh, we're gonna grade. That's really.
Oh, we're great.
Red pen.
That's better.
You prefer.
Oh, you prefer whom? Make try to do them sidewise. Otherwise, you just okay. I don't give you any.
Sam, why is it so many glitches? Oh, can you just write huge character?
This doesn't have any information on
Oh, okay.
Oh, that's it.
it. I mean, you can have it.
You need some bunch grading from one to one.
Sam already
No,
knows.
I'm friends. We're recording this.
It's mine.
Yeah, Sam.
It's not the friend.
Over here. Hey, do you have a color preference?
Oh, okay. So,
I think you graded him. Right here, so it's gonna be corrected in red if that's okay, man.
Oh,
yes.
Yeah.
I was having a breakfast at Red's, and it's not a good idea to try and walk fast in these shoes.
Oh, goodness, yeah.
Oh boy, this is really gonna throw it off.
It's like a lot, and I don't have pants.
You
I'm gonna need long pants. They're gonna last.
Oh,
I won't. Hey,
Rookie mistake.
I literally was like, I don't.
We got loud today.
So,
Hours.
We can just.
let's do another cycle.
There.
Yeah, so you grade this one.
Favors. No, I want great melodies.
Pass it on.
Again?
Okay, you can just. Well, just declare the grade yourself.
I didn't put a name on mine, guys.
I'm just gonna recognize each other by your handwriting, and then we'll recognize you soon.
Get that in mind.
Well, also,
No,
Actually, like, I'm gonna give you 60.
everyone is ready?
I think so.
yeah, only one thing is like.
In very scary red.
Yeah.
I'm running around.
I'm ready.
I hope
We're
it's.
just be down with things.
Will.
Oh, they're dry.
I'm gonna grade
Hope you do. You're a part of the ultimate mafia.
I'm the president of the.
You're the president.
I am for real. I'm the vice president. I was the president last year.
I like that movement.
Well, I did less working out than I did last year.
Bro,
Honestly, a good thing.
come on.
Oh, Rogers.
What?
Dr. Kenton Rogers.
Okay, Sam sent super card.
Bro, I was dead after.
Melody,
dropping
you should be to do this today. After what?
dropping.
They emailed me. Melody, talked to me
We're
last
doing
night.
one hand.
No one.
So I was like, oh,
Yeah, I did not even know that was coming up. I don't have a resume. I don't have any nice clothes.
my resume, I just printed it out.
So,
Yes.
so we have about 10 minutes to grade homeworks. I will guide you through solutions and tell what's the grading schedule. So the
That sounds like the best career. You might do any interviews.
so we need to get to the 100, right? So the last one should be
No,
40.
40 points.
Yeah, out of 100. Right? 40. Number 0 should be 10 because it's too simple. And then
0 and 100.
And
and then Then we can do 1 and 2.
Yeah, no, so we all have.
Let's do-
Breaking bad together.
let's do 20 and 30.
30,
Yeah,
20, 40, 10,
Yeah.
30, 20, 40,
yeah.
10, 30,
10, 30, 20, 40.
40.
Okay.
Okay.
So try to be generous to each other, give benefits of the doubt by
right.
any range. At the end of our little grading session, please add
Zeros.
up all grades and write them on the top of the sheet so that I can look at them. Yeah, it's everything should be out of country.
Fail.
Well, it doesn't matter. The
So
camera.
number one, if anyone, if you see explanation what is Fourier transform, just give full grade.
Okay. Yes.
0, it doesn't say anything about a Fourier transformation.
So and
Star.
so the and definition is as follows. So any function can be expressed in terms of expansion coefficients in basis of sines and cosine. Same as we were expanding our initial condition in basis of and sines and cosines do have a escalating integer number n, so we go to higher and higher frequency, right? You got it, you saw it, right? So it is a 10 points. Now, for the problem number 1, we do need to express this meandric function in terms of Fourier transform, which means we need to find coefficients a0, ak, and bk, right? So the function is periodic. As far as you go beyond L, it will be repeating, right? So we need to explore it only in the range from 0 to L, and we need to convert L to 2 pi, right? So we can proportionate, like 2 pi divided by L, and then integrate by angle from 0 to 2 pi, something like that. Okay, then the coefficients in front of coefficients in, and if you do see reasonable logic, even if the answer, final answer is wrong, give benefit of the doubt and scale somewhere between 0 and 10 for crazy. So the an expand the function in basis of cosines. The function, meandric functions means it is 1 in the range from 0 to L over 2 and 0 afterwards. Therefore, we can replace integral only to the range from 0 to L over 2. And let's, I don't know, maybe this is a little ugly, but you can see the cosine of the for n equals 1 have the 2 phases of positive and negative from 0 to L, and they are, if you multiply them by 1, they compensate each other upon integration. Do you see?
Yes.
So it will be 0, right? So we can believe that the a sub n for any n will be
0.
0. If you see, just do like +5 or design your for an.
You know about them?
I do.
Or
Okay.
what sheet? This?
So for the
Well, this are 0.
for the sines for the sine function, if n equals 0, you just integrate the cosine depending on whether the integer number is even or odd, we will have different results of integral. So if we do have the odd, then it will be non-zero contribution. You just take this half phase and multiply it by 1 and integrate. So and you'll get something. Right now let's keep. If it will be even, so like sign of double argument 1 and 2, then during the first half period it will be again alternating, and it will give 0. So there is an observation that coefficients in front of time b sub n will be 0 for odd and non-zero for even. So if you see this observation, even if the result is not ideal, you give a partial credit. And now let's okay, and let's consider it done. Next one. Oh, number 2 is just copy paste from the lectures, right? It was one of the definitions. Let me double check.
4 points.
If the person whom you are grading didn't neglect this assignment, just give this 20 points because it's quite easy. And the number 3 should be very similar to what we did in class.
Name.
So the meaning is that we expand the Gaussian wave function in the basis of imaginary exponentials. So you see connection to Fourier transform. It is the same idea. And one needs to arrive to the answer that it is square root of p sigma e to the power minus k sigma squared, where k is the inverse wavelength or proportional to momentum for the spin wave. So the mechanics, if you see correct answer, and I do mistakes all the time. If there is a factor like divide by 2, divide by 4, or in the power, let's forgive each other. Just see that it is a square root of pi sigma, and then exponential is k squared. This is important. If there is no full correct answer, let's just follow the protocol. K squared. So we follow to take this integral by identifying full square in the power of exponential, right? So same as we did, consider a squared 2ab and then plus b squared minus b squared. And then one can identify what you assign as a, what you assign as b, and subtracting a term. So if you see the trick, give a credit for it, 5 points, and then maybe 10 because it's a heavy problem. And then after identifying full square and putting the
You just do this part because
I'm sure.
so intuitive.
yes, this part goes outside, and integration variable is x. I was just stumbled for a minute because I saw k outside, but it is not integrated variable. We can do it outside, and then make a substitution and follow the lesson from Melody, how she derived and found the
Sure it is.
definite Gaussian integral, right?
What are these dots on?
And then you get this factor up front, which will be the answer and square root of pi from the integral. So try to give as higher points as possible. Now add them together and put them on the. No, we have two more things to complete. I am going to go to see the. Let's do not give the names in case someone is humble. Just give the what's the total
Don't worry,
grade
there's no name.
100%.
100.
100%.
100%.
99%.
No.
Really, it's
Okay, then I do not need to see. Just give it back to the.
Okay.
So pass on the homework. Everyone gets A, and Kate will continue further.
Oh, yeah.
Just if you select an exam will be presented by myself.
No, no. You already know my vote, so
Yeah, can we vote on that now? It is.
I think we've been thoroughly
Please.
scared by the homework.
Okay, next Wednesday, another homework. With, well, we need to do some. So, first one is commutation. I wanted commutation to be included into postulates in section by Sam, but I think he skipped it, so it gives me the right to give it as a homework. Don't worry, it isn't easy. You all will do it.
Is that the you want to do homework?
No, homework is all questions, but number one is easy.
Do we get to
I
cook?
should just give it to Sam.
Huh?
If we bring in a treat instead, if we bake something instead.
But
It has to be baked with the answer drawn on it. Like it has to be a cookie.
Wow, that's
and
weird.
not just the answer.
I don't know what that.
I think you're looking for a shortcut. Oh, if I bake something for you, can I give you double homework? Okay, so first one is communications, second book. Oh, just copy from the
Website.
from lecture notes.
Oh,
How to predict future, several ways. Number 3, normalization. By now we were kind of neglecting it, but it's time to focus on normalization. And the meaning is that integral of the wave function squared should be giving 1. And one just tweaks this factor n in order to get this normalization. Oh, find average position. Yes, the answer should be x naught if you normalize it correctly. So answer for problem 3 should be x naught, but we need to prove it. Reproduce formula. Okay, this one is just if you will be attentive enough, or if you will open lecture notes for our today's meeting, you will just copy paste into the problem 4. Oh, 5.
What?
Oh, extra credit.
Yeah.
Extra credit.
I thought I was trying to do number 6 myself, and it took me like more than an hour.
Oh, cool.
And then in one of the classes, I gave it as an extra credit, and students skipped and told, I don't know how to do number 1, 2, 3, 4, 5. And it's like 5 minutes for me to give number 6. And some of students who were strong in math, but not very strong in physical chemistry were getting big credit. So extra credit is like 30 extra points.
30. What is this new?
Just take an integral. Take an integral of sine x, sine 2x times x. It's a little non-trivial. You even if you are math skilled, you will not do it in 2 minutes. If you even with very strong mathematical muscles, it will be like at least 10 minutes.
Oh, yeah.
There are some tricky substitutions. UDV, VDU. If you
Yeah.
remember this.
For that,
Yeah.
we do that all the time.
Oh, that's good.
And her
And-
free time.
The
So do next Wednesday.
yes.
The 28th, folks.
Heard and understood.
Thank you. And number 5, it is standard. Well, first, number 5 is a door to our chapter number 3. So chapter number 3, after we are done with free particle, we will be doing so-called particle in the box, which is a best way to represent conjugated polymers, conjugated oligomers. And mathematically, the whole chapter will be resting on the foundation of solving this problem. So when we do have, it's the same section of the differential equations. If you know general equation, you need to find a particular. In this homework, and what we completed last lecture, we were matching particular solution to initial condition, right? Those who took differential equations can say yes. Those who didn't, like, okay.
Oh, yeah. Oh.
And what is the second way to specify, to match, to nail down a particular solution? Initial conditions and the correct word is written somewhere.
Boundary condition.
Yes. So match general solution to boundary conditions. So if you imply that at certain argument the function equals to certain values, you develop algebraic equations that allow to identify this four unknown constants. And this is the only mathematical challenge for chapter 3. The rest will be applications, more or less. Probably the easiest chapter. Okay. I still do not know when we do presentations, but I think you are already ready, right? We covered everything in MathHub, right? So let's do it old-fashioned. There are more subjects than people, but try to write your name near a subject that you like at most, and you.
Whoa, whoa, whoa.
Comes to me.
Whoa, no.
We can rock, paper, scissors over it.
I don't care.
Do you need to throw dice right at first?
I just need to read. Can I read what they on?
Yes. It is on the board.
Vectors.
So we need to cover everything. So if it is about 12,
Here.
it will be like. Yes. Movies is the if I would be in the class, I would select movies.
Yeah, I kind of want to do movies.
That's all you
then.
then.
Well, we each have to pick 3.
Well, if 3, it will be someone will need to do only one. Write your choices. Yeah. Well, try to select like movies and scripts, right? And for like selecting in
Ones that like go together.
yes.
Okay.
Otherwise, it will be a big headache.
11 and 12 or what?
Okay, but do it on the background because we already spent half of the time, and I do things to show. Okay. Where is? Let me humbly focus camera on. The best thing is
Wow.
we are studying waves.
No, yeah,
Yes, you want a different color?
only if you don't choose the ones that.
Which one? What block do you want? Do you want this one?
I'm gonna read one.
So here is a cheat sheet covering what I will be doing. It is.
We have to do it at each and every one. It is.
Sam.
My turn, whatever.
Yeah, move your bag.
That's okay. That's okay. I need to learn conclusion.
Whoa.
So what did we complete last time? I just noticed that not everything that what I write is recorded, so I need to be within some frames. So what did we stop last time? No, we went much more ahead of us. So I will, if I will give the whole story, I will fail for sure. Let's hope that you guys didn't forget everything. You have some memories of our previous meeting. So the goal was to find psi of xt, right? And by taking Gaussian integral, we found, and I'm using the cheat sheet, otherwise we will be a little longer than needed.
We did this.
Okay, how does it compare to what I write here? Is it close or far?
It is the same thing.
Okay,
Oh, wait. Does the pi need to be under a square root? I think the pi needs to be under a square root.
okay.
All right, this is good. I will accept this.
We did it.
So something like this, right?
Yes.
Objections? Or
Next check.
No,
or you don't care?
objection.
Here's a.
Not b squared over
Yes, B
one
squared.
a.
And B is ix and A was sigma over something. I may have already made a mistake, but what is important is so interesting and important that we are looking for wave function as with position and space as an argument, and we do have position space here and there, right? Yes. So we just plug in. And I'm just going to practice plugging in. So sigma, the 1 over square root of 8. No, I don't want to do it over time. Maybe I can skip it until that later on we will not just normalize. Otherwise it is too much thing. And e to the power b squared will be minus x squared, right? I times I is will be minus 1. X squared, and then we have 4 times sigma 2 times pi t.
No, sigma.
Sigma equals 6. Do you recognize this symbol?
Yes.
It's the same. It's a uppercase sigma, and this is lowercase sigma. And if one looks through Greek alphabet, the sigma comes in the same place where Latin S comes. They just if you try writing it, one can see the similar ways how you write them. So it just starts a little later and makes a little more curvature at the end. We were taught by you guys that wave function is not observable. The meaning comes either from expectation values or from wave function squared or wave function conjugated times wave function. So we this imaginary unit in the denominator of power of exponential is something that very hard to imagine. And there is a way to, there is a hope.
Oh.
There is a hope to believe that if we practice this P equals psi star psi,
I think it's
then we will get rid of imaginary unit. So let's try it. And another thing, later on we will learn. We already know from your postulates, and later on we will return again and again to the importance of normalization. So the factor in front of a function is needs to be determined by normalization procedure. And since we will need to perform this normalization anyway, there is a little cheating shortcut. If one just tells, okay, it is a constant that we will figure out a little later. If one does this trick, we can just speed up derivations, especially if you are not looking for all 10 digits, but for answer qualitatively correct. So I'll just put n squared, and then we'll process only the so e to the power, and then I flip sign in front of imaginary unit to match this little star. So minus x squared sigma plus here minus I h bar 2 h bar m t. Right, I just multiply this factor 4, and then once again the same thing. Minus x squared to sigma plus I can h t. The product of two exponentials means that it will be summation of their power, right? So we need to add together these two powers. Minus x squared over blah 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 times minus x squared over slightly different thing. One is minus, another is plus. How do we not multiply the plus? H between them. Plus, right?
Yeah.
So how do we add together the fractions?
Common denominator.
It's my pleasure to be in the presence of educated people. So minus x squared, I put this stuff in here. Sigma plus I h t here again minus x squared, and here I put this minus 2 sigma minus I h t, and in the denominator I need to do product of these two things, right? If this is a little a, this is a little b, it will be a minus b times a plus b, right? Which is
A squared minus B squared.
okay. Yeah, thank you. So will be this stuff for sigma squared, and then minus b squared. B squared will include I times I, will be minus, and another minus from here, so we do plus. Yes, I'm not right? Yeah.
Yes.
Plus, yes. 4h squared mass times squared. And this little box does serve as a power of exponential. So once again, probability distribution of x and t, which is probability to find our electron in the space from x to little x plus delta x at the time t. So it will be normalization squared, b exponential into the power. Oh, you may simplify the denominator as well, right? Otherwise, it will be too much of writing.
Yeah.
So different signs means this one will be cancelled. Agree? We?
No more me. I don't speak.
You know what
me,
lot of
me too.
My friend.
So
Load of more, I would put my,
she did right. She speaks French, at least the minimal basis. So minus x squared times 2 sigma divided by 4 sigma squared plus 4 t squared in h bar squared. Nous trouvons la solution de l'équation de Schrödinger.
what?
Nous trouvons la solution de l'équation de Schrödinger.
Big croissants.
No, that was Schrodinger.
Well, his famous core equation, and we need to solve it, right?
Isn't n also squared?
Maybe, let's check.
I was thinking that, but it's, I don't know.
Yes. So we were multiplying, so it should be squared. Yes, thank you. Melody plus 1. Oh, so otherwise.
But it doesn't have less than +5.
Well, you were deriving basically the whole lecture.
Is that I over A?
I over A? No.
No, that's
H bar squared. Okay. So how do we interpret? So basically we are done with derivations, but we are not done with the lecture. We need to analyze it.
Oh, I know.
so we normalized it.
Let's keep. Right now, normalization is not as important. Let's just return in our dreams to the sweet past before we started really doing this.
Wait,
A little well. So at time 0, our psi was assumed to be what? E to the power minus x squared over sigma. Right?
What class is in session?
So what is the meaning of the parameter sigma? You were teaching me
Probability.
No. You are disappointed. But so much better. One can just have a list of scientific terms and try them one after another. And there was a word you were teaching how to pronounce. If it is distribution, it has height and
Where? When? It's like we're going with you.
oh,
Yeah.
Yeah.
this. And you're maximum this.
With.
With. Better?
Yeah.
So I need to swallow.
Fit. Just fit.
Yeah.
With.
I can't speak, but I need to swallow the letter T, not it, but it.
Yeah.
Right?
Yeah.
So just remove T.
Yeah.
No T. This. And relax as a drunk person.
Yes.
I don't think one of these days we should just like come up with a bunch of words and just like kind of talk you different English speakers.
Squirrel.
Yeah, squirrel.
Squirrel.
Okay.
Well, French people couldn't say that one all.
You-
A lot of words.
I don't know where the rules come for removing letters. It's a big surprise.
Does English just like.
Make it up.
Say hanger.
Castle,
So.
salmon. Okay.
But that's fun.
Okay, back to the subject in remaining minutes. So the meaning of this sigma symbol is drunk man trying to speak.
That sounds like.
Okay. Now let's look in here and maybe do a few more simplifications. I don't want to erase because time is not enough, but I control. Move it a little down. Yes. And I will do something here. So n squared exponential, then I can do it in one line. And then what if I put like minus x squared? And then I divide numerator and denominator by
So
2
it
sigma.
becomes just 2 sigma on the bottom.
Yes, 2 sigma plus 2t squared
Can you just
over
put the m squared on top?
sigma. Not right now, later. Over sigma h bar squared. Enough errors or good enough?
You have the m squared
M squared.
plus 1.
Thank you. Yeah, oh yeah, yes, I'm plus one.
Look at me, I'm so good.
Yes, okay. Now, can we interpret?
No,
We
Yes.
do, yes. So let's call this stuff. No, sigma of t. Oh, because at time, and I think I did screw up something. There should be no factor 2. There should be
What?
just the same thing.
Wait.
If you find it out, let me know and we will fix it. We have limited time to communicate general idea. So I admit I made some mistake.
Oh, you see,
You see?
wait, no, wait.
Come and correct if you can.
Minus x squared times 2 sigma minus another x squared times 2 sigma. Shouldn't that equal to negative 4 x squared sigma?
Make your derivation, submit for extra credit.
Oh, I see, I
Okay.
see, I see.
Just time is really running out and we need too much. But with even with little mistakes, in principle, qualitatively it is correct. So we can treat the denominator here as a new sigma, as a time-dependent sigma, right? And we see that at time 0, it is as it should be equal to initial sigma. If it is not, it's just my fault. But it starts from initial sigma and then escalates as time as a square of time. This is the best discovery we ever made. So the width
That was good.
the width of the wave packet of the distribution increases and increases not linearly but quadratically, bigger and bigger and bigger and bigger. And when we started the subject, we were posing 2 questions: whether how the center is moving and how the width is changing, right? So and we did found that the width quadratically increasing. So maybe I can just read this on the this little area and do a quick program. So time 0, sigma at time 0, and then it goes quadratically, which means we start with narrow wave packet and then it becomes broader and wider, right? As time goes by. This is a true discovery. There is a little more. If we look at your homework answer, so the wave function is a function of momentum or k, which is momentum over h bar. Square root sigma d e to the power minus k squared sigma divided by 4, right? Now, in the space of momentum, in the mathematical abstract space where coordinate is value of momentum or value of the scale. This is also a Gaussian function, right? But the meaning of the width in the momentum space is the stuff in the denominator. So we can rewrite it as e to the power minus a squared over sigma sub p. And sigma sub p would be 4 divided by our initial sigma, right? If we take wave function squared if you look for probability distribution in the momentum space. Then those are little details. So now we should come in the remaining 40 seconds to the answer to the question that Sam did surprise me during our first meeting. He readily told if one can measure position and momentum simultaneously. Okay, now let's put it in a mathematical way, 25 seconds. So if we express uncertainty in the position as function of t, and uncertainty of momentum as function of t, then for momentum, we will have time independent, right? It doesn't change over time. And for position, it does change over time. And we will get for sigma times 2 sigma plus 2a squared over sigma squared t squared. So when we meet on Friday, I will correct most of my errors. I need to fix some factors, but the reason the meeting is that at time 0 they take minimal value when the sigmas are entering, and any time past 0 it continually increases. So product of uncertainties of position and momentum can only increase, and it cannot be smaller than certain value. If we change time direction backwards, it's still square. It's still will be increasing. So no matter we take uncertainty of position and momentum, their product will only increase. It means they cannot be, it is interpreted they cannot be merged simultaneously. So meeting is done. Let's see each other tonight. And from here,
I'm excited to see you guys. I'm not excited to be there late. Yeah.
oh, I'm sorry.
That's okay. I'm in.
That's right.
They're not coming.
I haven't finished.
Dinner. It's gonna be a hot day.
Oh.
Better be a hot day.
Dimitri,
can we?
Yeah, family time.
Is this so?
No, it doesn't.
It's not very good.
I don't want to start this meeting. Melody.
And then minus
Sorry, Elsa.
this as well.
You want to use my phone?
So why is it
This
better
guy
to
and
use
then
your
the
phone?
words.
Oh yes, yes. Oh, thank you.
Does that make sense?
Yes, yes, it does.
Like,
Okay.
whether you're gonna go or you're not, you're gonna go.
Thank you.
Right now. Yeah, I need a change.
Freaking pants.
I'm so confused on why you're.
Use because you're going home to Teams, right?
Yeah.
I'm going to the Fargo Dome, so why does it matter?